Seated on my laptop screen, ready for the Python scene. All those lines of text so clean, let's code and chase that dream. Python world, here we go. Write the script, let it flow.
In this video, we're going to continue our exploration of object-oriented programming. In particular, we're going to be taking a look at class attributes and methods. In a previous video, we took a look at instance attributes, which were specific to each object or instance of a class. For example, if we had a dog class that had a name instance attribute, each instance of that class would have a different name. Each dog would have a different name. Class attributes are a bit different. They're shared across all instances of a class. And these are defined specifically within the class body, outside of any methods. And they're very useful for setting up properties that are common to all instances, but might change over the time. They're not necessarily constant. Let's take a look at an example. Here we have a bank account class. And what's interesting here is that we have a instance class attribute. And this is defined outside of any method, and it doesn't use the self keyword like the instance attributes we saw before. This is setting up an interest rate that's going to be shared with all instances of the bank account class, and we're going to be starting that out at 2%. Down here, we can see the instance attributes that we took a look at in a previous video. Here, each instance of the class is going to have its own account holder and its own balance. These will be different for each instance of the class. So how do we access or modify class attributes? Well, again, we're going to be using that dot notation, but instead of using self or the object's name, we're going to be using the class name. So the syntax is going to be the name of the class, such as bank account or dog, dot the class attribute name. That's the name of the class attribute. Let's take a look at an example where we access the value of a class attribute. And here again, we have that bank account class. The only difference is we've added a new method called apply interest. What this method does is fairly straightforward. It calculates the interest on the current balance and then adds that back to the balance. Perhaps the owner of this bank account gets a little bit of interest every month. This would calculate that and then update the balance instance attribute. To calculate this, we need to access the interest rate. Since this is a class attribute, the way we access it is by doing class name, this case bank account, the dot notation, and then the name of the class attribute. In this case, it's interest underscore rate, and that allows us to get that access to that 0.02 or 2%. We then multiply that by the current value of the instance attribute, balance. And we store the result back in balance. Just like with instance attributes, we can access class attributes outside of the class that they're defined in. However, unlike instance attributes, we have two different ways of doing this. The first is using that syntax we just saw, with the class name, the dot notation, and then the name of the class attribute. This notation allows us to access class attributes even if we don't have instances of the class created yet. The other way we can access them is through the object. In that case, we use the object name, the dot notation, and then the name of the class attribute. There's some trade-offs between doing this, and they work slightly differently, and we'll get into that a little bit when we talk about namespaces. Let's take a look at an example. And here we're making two instances of that bank account class that we just saw. The first one is going to have an owner of Alice and a balance of 1,500. The second is going to have an owner of Bob and a balance of 1,500 as well. Next, we are going to be printing out some values. And what's interesting here is that we're accessing the interest rate class attribute in two different ways. The first way, on the first line, we're printing out bank account and then the value of the interest rate class attribute. The way we're accessing that is through the class name dot the name of the class attribute, interest rate in this case. That means we're directly accessing it, and we don't even necessarily need an instance of the class to do this. So that's going to print out its value that was already defined in the class to be 0.02. The next two lines are accessing it in a different way. They're going through the object. So we have the object name, either Alice account or Bob account, the dot, and then interest rate. Now this works a little bit differently. What it does is Python first checks, are there any instance attributes with this name? are there any instance attributes named interest rate? In this case, there isn't, so it falls back onto looking up the class attributes. In this case, there is a class attribute named interest rate, so it falls back on that and returns that value. What this looks like is this. All of the values are going to be 0.02. Now, if we happen to have an interest rate instance attribute as well as the class attribute with the same name, we'd call that a shadow copy, we might get a different result. We'll take a look at that more later in the lecture. Now, the next line is where we update the value of the class attribute. Again, we're using the class name dot class attribute syntax for this. And what this does is it updates the value of the class attribute from 0.02 to 0.05. Now, importantly, because this is a class attribute, this is going to affect all of the instances of this class and not just one instance. And we're going to see that in these lines here. These are the exact same print lines. I think we just have an extra line break. And the output we're going to get is going to show that the value of interest rate was updated for all instances. So it's updated for the class attribute, which we're accessing directly, and it was also updated for both Alice and Bob. So this can be very useful in cases like this, where we have some sort of value that is common to all of the different instances, and it might need to be updated occasionally. For example, in a banking system, you might be updating the interest rate daily or monthly or so on. So to summarize, updating a class attribute updates it for all instances of that class. In this case, we updated interest rate for bank account, and it updated it for all instances of the bank account class. Now let's look at a more in-depth example. Here we're taking that bank account class again, and we're adding some new methods to make it a little bit more interesting. We have two getters. These are methods that return an instance attribute. In this case, we are returning the balance in getBalance, and we're returning the name of the account holder in getAccountHolder. We're also adding a deposit method, which allows us to deposit money into the account, and it has some simple error checking to make sure that we're not depositing a negative amount. And we also have a withdrawal method now, which allows us to withdraw money from the account, and it checks that we're not doing something silly like trying to withdraw a negative amount, and we're also checking that it won't make the account go negative. We can't withdraw money that we don't have. And we're going to test this out by making some instances of this class and trying to call these methods as well as manipulate that class attribute interest rate. And we're going to try this out in PyCharm. So let's switch over there now. Here we are in PyCharm, and we have BankAccount.py opened up, and this is where we define the bank account class. Just like we saw in the slides, the biggest changes are adding the withdrawal and deposit methods. Deposit basically just adds the amount to the balance after a simple check to make sure it's not negative, and withdraw subtracts the amount from the balance after a simple check to make sure it's not negative, and that withdrawing it wouldn't make the balance negative. Now the way we use this class is in this other file here, ex_10_4.py. And the way this works is it's going to import the bank account class. And we're importing that from the bank account module into this current module. And what we're importing is the bank account class. Now what we're going to do is we're going to trace through this using the debugger. We're going to start on this first line here, which is going to be creating an instance of bank account, which is going to be this Alice account object. So let's start up the debugger now. Right now we're paused on this line here, right before we create an instance of bank account. So let's do that now. We can see that we now have an Alice account object, and it has two protected attributes, balance and account holder. And we also have our class attribute here called interest rate. Let's run the next line. Okay, we just ran Bob account, or rather we created an instance of bank account that was called Bob account. And again, it has its own protected attributes and the class attribute. Now it is a bit deceptive how PyCharm shows these as twice, because again, these are referencing the same class attribute, so they're connected. Whereas these ones are instance attributes, and they're not connected. Let's go to the next line. So we just deposited $100 in Bob's account, and we could see that Bob's instance attribute balance has been updated to 100, and this had no impact on Alice. Bob started at 0 and now he has 100. Alice started at 1,337.42 and it remains the same. Now we're going to make a withdrawal from Alice's account by calling our withdrawal method. And we can see that happened, and now Alice only has 1,000. Now to the console, we're going to print out the current balance of Alice's account, and then we're going to print out the current balance of Bob's account. I'll run both of these. And in the console, we can see Alice's current balance is 1,000, and Bob's current balance is 100. And the way we did this is we used our getter, getBalance. So if we take a look at the class, we can see we have there it is, getBalance method, and it simply just returns the current balance. And then we printed this out with this f string, and we rounded it to 2 decimal places. Now what we're going to do is run this for loop. And what this for loop does is it simulates depositing $100 each month in each account, and then applying a 2% interest rate to each account. And we're going to do this 12 times for 1 year in total. Now let's see what happens when we run it. So first we are going to be depositing $100 into Alice's account, then Bob's account. And we're doing that with the deposit method. And we can see both balances were updated, and they are still separate for each object. Now we're going to apply the interest rate. And we can see both balances have been updated, and the interest rate for both was 2%. That was the value of the class attribute interest rate, and that's the same for all instances of that class. And this would keep running for each month, and we can see the balances are slowly getting higher, both from that $100 deposit as well as that 2% monthly interest rate, which is a little bit unrealistic. Okay, we finally ran through the loop. All the interest has been applied, all the deposits have been applied, and now we're going to print out the new balances. We can see those in the console, and we also rounded them to 2 decimal places to help with any kind of floating point error. Now what we're doing here is a little bit more interesting. Now we're going to change the interest rate. And again, this is a class attribute. So it's not going to just affect one object or the other, it's going to affect all instances of this class. So we can see right now the interest rate is 0.02, and that's listed for both Bob and Alice. Let's see what happens when we update this. And we can see that interest rate has now updated for both objects, even though it was just one line here and it didn't even reference those objects. Again, that's because class attributes are shared through all instances of the objects of the same class. Now again, we're going to apply the same thing, but this time the interest rate has changed. So we'll do that quickly. And we can see that they are applying the interest rate of 0.75 this time instead of 0.2. So changing that class attribute didn't just change it for what it shows the value is, it also changed it for the methods that access that class attribute. Oh, and then we ran the last 2 lines. We're printing out the last balance. So here we can see Alice's balance after 2 years and Bob's balance after 2 years. The important thing to get from this is by changing this value here, is it affected all objects or all instances of the bank account class. Okay, let's switch back to the slides right now. And we're back. And of course, in the slides, I also have a copy of the output. But you can download these files from our learning management system if you'd like to try them out for yourself. Now, let's summarize the differences between class and instance attributes. Instance attributes are specific to each object, and we define them using the self keyword. That's that parameter that we give to methods. Class attributes are shared across all instances of the class. Changing an instance attribute's value only affects that specific object, whereas changing a class attribute's value affects all instances of that class, and they both have their different uses. Now, the next thing we should take a look at are class and instance namespaces. Objects in Python have 2 different namespaces, the instance namespace and the class namespace. Instance attributes live in the instance namespace, and class attributes live in the class namespace. However, even though the class and instance attributes have these own unique namespaces, we can still access class attributes using the self parameter or the object itself, usually outside of the class. And we did see an example of that earlier, where we were able to access the interest rate class attribute through the object rather than through the class name. Now, an important thing to note about this is if a class and an instance both have an attribute with the same name, then the instance attribute is always referenced. So if we also had an interest rate attribute in BankAccount that was at the instance level, that means it's defined for each instance of the class and it can be different for each instance of the class, then we would get that instance attribute rather than the class attribute if we tried to access it through self or object. If it doesn't have that, then it will fall back on looking up the class attribute. Let's take a look at an example of this. And now we have a new class named product. And at the top of this class, we have a class attribute that defines the default shipping rate. And we're going to set that to $10 to start with. We also have an init method, and this is sort of the constructor for the class that's called when we create an object of the class. And it's defining two instance attributes, name and price. We also have a calculate total cost method, which calculates the total cost of this product, and it includes the shipping rate. And the way we get the shipping cost is by looking it up through the self keyword. This means that we're first going to check that namespace for instance attributes. We won't find it because we never define a default shipping cost instance attribute. So then we fall back on looking for a class attribute. In this case, the default shipping cost that we defined as $10. The other bit of code we have here is the display product info method. And this is basically just printing out all the different attributes of the class, both the name, price, the shipping cost, and the total. And the way we are looking up, again, the default shipping cost is through the self keyword. So once again, it's going to check the instance namespace, find it, and then it's going to fall back on the class namespace. So let's take a look at an example of using this class. So here we are defining two instances of the class, product 1 and product 2. Product 1 is going to be an electric guitar, and it's going to cost $800. And product 2 is a drum kit, and it's going to cost $1,200. So what are we doing with this? Well, we are first printing out before modifying shipping costs, and then we're using the display product info method to print out the values for these classes. This would look something like this. First, we get the values for the electric guitar, and then we get the values for the drum kit. This includes the base price, the shipping cost, and the total cost. Nothing here is too surprising, but like I said, we are defaulting to the class namespace because we don't have an instance attribute named default shipping cost. So in this case, we get $10 for both instances, which is hopefully what you expected. Now we're adding a few extra lines here. And what we're doing is we're going to be changing the value of that class attribute. So we can take a look at this as different namespaces where each one of these attributes live in. So at the top of the class, we defined default shipping cost to be $10. So that's going to live in the class namespace, which we can see as this little box here. We have default shipping cost, and it's equal to 10. Now, when we make an instance of product 1 in this case, there is going to be an instance namespace. So within product 1, we have two instance attributes, name and price. Name's going to be electric guitar, price $800. For the next instance, product 2, we also have a unique name and price. In this case, drum kit, and price of $1,200. Now we do something interesting here. This looks like that we're just accessing the class attribute, but we're not actually. What this does is it defines a new instance attribute that happens to be named the same, default shipping cost. So this is added to the product 1 namespace. Product 1, the instance of product, now has a new instance attribute named default shipping cost that's set to be equal to 25. And this has no impact on the default shipping cost class attribute, which is still equal to 10. Now on the next line, we are accessing the class attribute. And the way we do this is through the class name dot instance attribute name. And this updates it to 15. But notice how this had no effect on the default shipping cost for product 1. They're not linked together. So if we change the code again, and now we print out the values, this is going to have a noticeable effect. So for the first line, we're going to output the values for product 1 using the display product info method. And it's mostly probably what you expected, at least for the first 2 lines. We have electric guitar for name, and we have 800 for the price. These are both instance attributes. Now what might be different than what you would expect is the 25 for the default shipping cost. The reason why this isn't equal to 15, which was the default shipping cost that's stored in the class attribute, is that we have an instance attribute with the same name. We call that shadowing. So we have an instance attribute that shadows the class attribute. When that happens, the instance attribute is going to give in priority. So it gets a result of 25. So interestingly here, even though we edited this outside of the class, we added an instance attribute called default shipping cost and set it equal to 25. This also affected the result of the display product info method. Now, what's also interesting here is what happens when we output the values for product 2. In this case, it's mostly what you expect, but we also get 15 here for the default shipping cost. Because this change was only done to product 1 and not product 2, product 2 doesn't have an instance attribute named default shipping cost. So it falls back on the class attribute, which is still equal to 15. So for the drum, product 2, we get 15 for the shipping cost. This can be quite useful because it means that we could have certain instances set to the default class attribute value, 15 in this case, and we could manually adjust some by adding an instance attribute like we did for the electric guitar product 1. Now let's see what happens when we output the value of that attribute directly. So we have 3 new print lines. The first one is going to be outputting the value of default shipping cost for product 1. The second one is doing the same thing, but for product 2. And the last one is using the class name notation to get the value of the class attribute default shipping cost. So for product 1, we are going to get a result of 25 because this is going to be referencing the default shipping cost instance attribute that's only in product 1. For product 2, there is no instance attribute named default shipping cost, so we get 15 because it is accessing the product class, the class attribute stored in the product class, that is. And for the last one, we are directly accessing the class attribute, so this is accessing the 15 in default shipping cost. So we have 2 different ways of accessing class attributes, and that can be a bit confusing. So here I have a few guidelines on which way you should use. So if everything's the same, you're not trying to do anything special, you should prefer the class name notation. That's class name dot attribute names. So explicitly access class attributes to avoid any unintended shadowing by instance attributes. This makes it very clear also to the people reading your code what you're trying to access. They don't have to try to trace through it and figure out, is this an instance attribute? Is this a class attribute? So in most cases, you should be using the class name approach. We also want to avoid modifying class attributes via self for the same reasons. Changes made through the self parameter, that self keyword, may create an instance attribute. For example, if we didn't mean to make that new default shipping costs instant attribute, we could be thinking that we are changing the value of the class attribute, which could get quite confusing and hard to debug. So when you want to change the value of a class attribute, make sure you use the class name. Don't make it ambiguous like this. And lastly, access class attributes through the self keyword, that self parameter, only when necessary. So if you are able to use that class name notation, use that. So don't use self unless you use self attribute if you want that flexibility that we saw by having sort of like a default value and then being able to override that value. So the only time we should really be accessing class attributes like that is when we want that ability to override or default a value. Now we're going to move on to talking about class methods. It's a very similar idea to class attributes, and just like how class attributes are bound to a class rather than an instance, class methods are going to be bound to the class rather than an instance of that class. Class methods affect the class state or provide functionality relevant to the whole class, but they can't edit or manipulate or even access the instance attributes of specific instances of the class. They only can operate on class attributes and other aspects of the class as a whole. And the way we define them is a little bit different than what we've seen before. We have to use a decorator, which is a special statement that we put before the method to let Python know that this is a class method. The other thing we do differently is instead of giving it a self parameter, we give it the CLS parameter, which refers to the class itself, rather than an instance of the class. Here's the syntax. So inside of a class's body, in this case it's just called class name, we use the decorator called class method. It always should say class method. And then we define our method. But instead of self, we give it CLS. So once again, because we don't have access to that self parameter, we can't access the instance attributes of this class. We can only access the class attributes. Let's take a look at an example. And again, we're going back to that BankAccount class. Here we've updated the BankAccount class with some getters and setters for interest rate. And because this is a class attribute, we're going to use class methods to do this. So again, we have our interest rate. The only change here is that we put an underscore on front to denote that this should be private. It shouldn't be accessed from outside of the class. Instead, access is going to go through our get interest rate and our set interest rate methods, which are going to be class methods. Here we have set interest rate, and we're using the decorator class method to let Python know that this is a class method, and we're also providing its CLS parameter first, rather than the self parameter. And what we're doing is we're going to use that CLS parameter, which is the same as the class name, and we're going to use that to manipulate the class attribute. In this case, we do a simple check to make sure it's a valid interest rate, it's not negative, and then we update the class attribute through the CLS parameter, and we set it to new rate. So this has the effect of updating the interest rate for all instances of the BankAccount class. Now the second method here is fairly similar. It's a class method. It's taking CLS as the only parameter, which is the class, and it is returning the value of interest rate. So let's take a look at using this class with a few lines here. What we're doing is we're first going to print out the current interest rate. We're going to modify it using set interest rate, and then we're going to print it out again to see what happened. So here we're accessing it through the class name, BankAccount.getInterestRate. So this way we're accessing it is by calling the getInterestRate method, and then that's going to look up the value and return it for us. Remember, since we've put that underscore, it means it's private, so we shouldn't access the class attribute directly. Next, we're going to update it using set interest rate to 0.1 or 10%, and then we are going to see how it changed. And the result shouldn't be too surprising. The first time it's going to be 0.02 because that's what it started off as. We updated it on the second line to 10%, 0.1, and that's what we get in our second call to it. So what are the best practices for using these class attributes and methods that we've discussed in this video? Well, the first one is to clearly separate class level and instance level data and behavior to enhance code clarity and maintainability. We want to try to keep them separate and as clear to the reader as possible. One of the ways we can do that is avoid accessing class attributes through that self parameter or through the object, unless we have a special reason to. We also want to be cautious when we're modifying class attributes because it's very easy to accidentally create a instance attribute, or it could be making a change to all instances of the classes that rely on them, which we probably don't want to do unless we intended for that. So we should prefer accessing class attributes and class methods via the class itself. That'd be either using the class name like className.attribute or className.method, or if we're inside of a class method, it'd be through that CLS parameter. And we want to do that over using the self parameter or object to make our code as clear as possible. We also want to avoid using class methods for instance-specific behavior. Remember, class methods aren't going to have access to your instance attributes, so class methods should only be for class-level logic and manipulating class attributes. We should also avoid overly relying on class attributes. We should really only be using them if there's some sort of constant that needs to be set for the class, or some sort of configuration point like interest rate that applies uniformly to all instances of that class and always changes together. If it doesn't do either of those things, then we're probably better off using an instance attribute. That's all I have for you in this video. We're not going to be going too far into class methods in this course, but make sure you are familiar with class attributes. They can be quite useful when we need a constant or some sort of configuration point that applies to all instances of a class. Thank you for watching, and have a great day.